Greetings everyone, my name is Tsvetoslav and today I will be presenting you how to deploy and manage containerized applications with Rancher. But first off, a few words about me. I have more than 5 years expertise in the IT field and I'm currently working as an Accedia as a DevOps consultant. My hobbies include all kinds of different sports, but mainly it's rugby, tennis and running. Also, I'm really passionate about learning and using new technologies such as Kubernetes and the different cloud providers such as AWS and Azure. And of course, a bit about what Rancher is. To summarize it, it's a complete stack for teams adopting containerized applications. It helps in managing multiple Kubernetes clusters and tackling operational and security issues. Also, it provides different kinds of tools for running containerized workloads. Or in other words, it's a single management platform for multiple Kubernetes clusters. I'm going to talk about a bit the architecture that we'll be seeing today. So we have an application cluster VPC that contains 4 subnets in total. 2 of them are private and 2 of them are public. In the private subnet that we can see on the top, we will have our EKS cluster where it will be located, a node which will be hosting our simple Angular application, and a classic load balancer that will be located in the public subnet and it will expose the traffic to us. The other architecture is for the Rancher cluster, and as you can see, it's the similar. The VPC is different, but it still has 4 subnets, 2 of them private and 2 of them public. Our EKS cluster will be located on the private subnet, where our node will also reside, hosting our Rancher pods. And in the public subnet, we can see our network load balancer that will be located there and expose the traffic to us. So the process that we will be seeing today in our presentation, we are going to commit a code change to our repo and we're going to push it. And this will trigger automatically a pipeline that we've created, which contains a Docker task that is going to build the image with the new code. Afterwards, there is a step that is going to be executed and is going to push our container image to our Elastic Container repository. And finally, we are going to deploy this new image or application with our Rancher API. So, the technology stack that we'll be seeing today. For the infrastructure, we are going to use AWS as a cloud provider. EKS CTL is a tool that I've used and I'm not going to show today, but I'm going to show the files that I've used in order to create the 2 clusters. EKS CTL, for those of you who don't know, is an official tool for managing, not managing, but the creation. It's used for the creation of clusters in AWS and their node groups. Docker will be used for building our images. Helm is the package manager that we'll be seeing. It's a package manager for Kubernetes resources, different kind. Rancher is one of them and we are going to deploy it via Helm. And last but not least is the Azure DevOps, which will be our CI/CD process that we'll be seeing. The agenda on a high level, first off, we are going to deploy resources into our Rancher cluster with Helm. Afterwards, we are going to create resources in the application cluster with Rancher. And lastly, we are going to demonstrate the CI/CD process and you're going to see this in action. So without any further ado, let's jump into the live demo. So first off, I'm going to pick up and I'm going to configure my kubectl to use and to find the Rancher cluster. Okay, it has been successfully configured. So if we execute kubectl get pods, we are going to see all the service pods that have been deployed that are needed. Afterwards, we are going to add the repo from this chart. As you can see, I've already added it, so it won't be added again. And here we are going to use install command that is going to install the cert manager. This is how we named it, from which repository or which chart is going to be used, which is the namespace where it will reside, to create the namespace if there isn't one, the version, and we are going to set custom resource definition installation to true. And while okay, that was quite fast, so we will continue on with installing the Ingress engines. I won't be adding the repo since I already have it and it's not needed, but as an initial step it is a mandatory thing to do. As you can see, it follows exactly the same structure. We are going to deploy the Ingress engines from this repository, this chart, and again the namespace, creation, and we are going to add some other arguments there, defining that our load balancer will be type network load balancer and the Ingress class will be from engines. So I would want to show you the two YAML files that I used before that with EKS-CTL in order to deploy the two clusters. As you can see, they look exactly the same. The only difference is that they have a different name and different subnets where they have been deployed. And the desired capacity for our application cluster is 2 nodes, and for our rancher is 1. Since the application would require a high availability, the rancher cluster is a deployment tool and it's not a necessity. So getting back here, we can see that things have been installed successfully. We can check that with another kubectl get pods command, which we will see that everything is here. So now on, we are going to pick up the endpoint from our network load balancer. This is the external endpoint that I was talking about in the presentation, where our rancher UI will be located and will be visible. So afterwards, I will need to execute this helm command that is going to install our rancher, and I need to specify the hostname where it will be. While I'm showing you, we're waiting for this to be installed. Okay, it was quite fast, but I will still want to show you the in AWS UI the clusters so you can see them. The application cluster with the 2 nodes, and if we go back, we can see the rancher cluster as well with a single node, and both in different VPCs. So now what we will need to do is we will need to edit the ingress and add an extra line, and this is a mandatory thing in order to work. So here under annotations we will need to add the following line specifying that our ingress class is of type engines, and this is a must. So while we are waiting for this to take the changes, actually we can check it here under EC2, and if we go to load balancer we can see our endpoint and it's still in provisioning state. So while we wait, let me show the configuration to the VPCs so you have a better view on that. As I did say, we have 2 clusters. One of them is rancher, one is then for the application, and as you can see they are both in separate CIDR blocks. If we open them and we check the resource map, it's going to show us how actually these things are linked. We have public subnets and a public route table, which will be directing traffic to the internet gateway, and we have private subnets with 2 different route tables that will be directing the traffic to our NAT gateways that we have, and we have exactly the same structure on the application cluster itself. Okay, so if we go back to EC2 and we check the load balancer, it's in active state, so now we can copy this and paste it here and we should be good to go. While we wait this to load, we can check if everything is fine, our pods and everything that we've installed here. Okay, still have some jobs that are running, so during this time I'll just open a private window just in case that it did some caching and it's not loading. Okay, let me try in this window here as well. Okay, everything is up and running and completed, so we should be good to go in a couple of seconds and we would be able to see our UI. Sometimes it's taking a bit longer to load. which is the unpleasant part of this presentation. While we are here, I might be able to show you a repository where we are, okay, actually it has loaded now, but still I'm going to show you the container registry that we'll be using. So we have two repositories. One, it will be used for our deployment agent, and the other, it will be used for the application, the Angular application that I talked about. So we have an image here, and the tagging is specified. So we have version 1, this is hard-coded, and as you can see here we have the date, the today date, 2023, 24th of September, and this is a predefined variable in Azure DevOps. It's called build number, and it's being used, and here it's the number of the pipeline that has been run today. So this is the first run that it has been done. So getting here, opening the rancher, we will be able to see our UI finally. And as you can see, when it's a Helm installation, there is a command that will be providing the initial password that we have. So running it here, we'll be picking the password, apologies, and we'll be logging as a local user, as an admin, and we would have to create a new password, which is mandatory. I would just pick up the one that has been auto-generated and checking the box for the licenses. I'm going to put the password here just to have it, and here is it, our UI. And as you can see, we have our local cluster. The local cluster is the one that we've installed Rancher on. So here we have a couple of metrics that we can see, CPU, memory usage, number of pods, and how many there are. So let me import the existing application cluster so we can see it as well, and we are going to call it application cluster create. And now we are going to get a command that it's going to install the cluster agent. The Rancher cluster agent is going to be installed on this application cluster, and this will allow the Rancher cluster to communicate with the application cluster and use the API to update any kind of resources that we want. So I'm going to authenticate I'm going to add to my kubeconfig the application cluster. I'm going to clear the screen, and if we get the pods, now you will be able to see that we only have the system pods since we didn't install anything. So getting back here and picking the command is going to install our Rancher cluster agents that we require, and many other resources, as you can see, with service accounts, namespace, and anything that is required for this to function. I'm going to clear it, and as you can see now it's in a pending state. And while we wait in this pending state, I will go here to the cluster management, where we will be navigating shortly in order to create all the different resources that we will require for this demonstration in our application cluster. And while we are waiting at here, we can check it how the pods are being created in the cluster itself. So as you can see, Kettle cluster agent, one of them is creating, the other one has been created. So while we wait, I'm going to do something. There is, under the preference menu, there is an option that we would need to enable. Check the box. It will be the view in API. So this will allow all the different resources that we have on the cluster to have the Rancher API, which is the main thing that we all gather here to show you how to deploy and manage containerized applications through the Rancher API. So I've enabled this, and well, we can see that the application cluster is up and running. As you can see, since we have two nodes of T3A medium type, as you can see, the pods here can be 34, memory is twice the big, and the CPU as well. So going to the application cluster, first off, we are in this menu where we, as I said, we have a monitoring, we have some events, so this would be logging. We can see all the different things happening here. So we can check the nodes from here. It presents a really nice graphical overview of the cluster itself. We have the workloads, so if we go to pods and we change here to all namespaces, we would be able to see all of the namespaces that we have here. So getting back to the cluster and to the project and namespaces, under the default, project default, we are going to create a namespace for our application, and it's going to be called application namespace, for example. So as you can see, now it has been created, and if we click the three dots, we have an API for that. So we can see all the different resources and use the API, the Rancher API, in order to update that. Okay, afterwards we would go to workloads, and under deployments I'm going to create the application deployment. So you just click create here. You can change the namespace here, and it's going to be application namespace, and we are going to call it application for convenience. The container name would have the same name, and we would need to specify the image in our registry, which would be this one. So pasting it here, and as you can see below, there are like a lot of things that we can configure through this. One thing that I would like to show you and configure, which is really nice, is some of the probes that we have. So I'm going to create a liveness probe, and I'm going to say that I need it on port 80, and it's going to be just slash. On 10 seconds interval, it's going to check, and we have 1 success threshold to 3 failures. So we are going to create it now, and it's going to be up and running at some point. So now we can go to pods and we can actually check it. So we can open it and we can check the logs. And as you can see, we have the probe here. Okay, but this is only internally accessible from the cluster. So we would need to expose it. And as I did explain, we will create a classic load balancer for this. So from the deployment itself, I will open up the application, and apologies, I'm going to check the config in the pod, and I'm going to pick up the key as a selector, and I'm going to paste it here because I will need it, and the whole value for that. So going back to service discovery, I'm going to create a service, and it's going to be a load balancer in the application namespace, and I'm just going to call it application LB. The port name, you can call it whatever you like. It's going to be the engines. Oh, as it seems, my battery will be getting empty soon. So listening port would be 80 on the service or the load balancer, and we will be targeting port 80 on the container itself. And we need to go to selectors, as I did explain, in order to be able to pick up the pod that we want to expose. And as you can see, matches 1 with 1 pods, which is our one, and we create it. And now it's pending. So if we go back to workloads and we go to deployments and we click here, services, as you can see, we did pick the application LB from here. So now we have an endpoint that will be exposing our traffic, and we can paste that here. I will just wait so it doesn't cache out during its still provisioning the cluster, still provisioning the load balancer. While we wait for that, we can go to workloads, and I'm actually going to create now a pod. But first off, I will need a secret, and I'm going to create a secret, which would be of type opaque, but I don't want it under the application namespace, since this will be strictly for the deployment agent that we'll be using. So even from here, I can create a new space, and I'm just going to type Rancher deployment agents, for example. It will be Rancher deployment agent secret. And we would be having 4 key value pairs, which I have them here. This is the AZP URL, the AZP token, the agent name, and the pool that we'll be targeting. So the pool, I've decided to call it Rancher deployment agents, and the agent name, it will be Rancher deployment agent. The AZP URL, it's the one of the organization in Azure DevOps, and the token will be something that we will need to create. It's quite easy, from personal access token, and we are just going to say new token, rancher deployment agents, and we would need only agent pools read and manage, creating it here and picking up the token and pasting it here. So now we have created a secret, which we can see here. Now let's go back to workloads and open the pods, and we are going to create our new pod with the deployment agent. And as you can see, rancher deployment agents, rancher deployment agent, same name to the container, and we are going to use the deployment agent that we have here that I've previously deployed, just to save time, and it will be out of the scope for this. And here under environment variables we are going to add our secret, and it's going to be defined quite simply since they are in the same namespace. Before doing that, I would need to go here in my Azure DevOps project settings, and I would need to create an agent pool, and the agent pool would have the same name that I did specify here. So it's rancher deployment agents. Good. And now we are good to create our deployment agent. Okay. So it will need some time to create. During this time, I'm going to pick up my API keys. So this is something that you create, and it's necessity in order to be able to deploy using the rancher API. So I'm just going to call it rancher API key, and I'm going to create it, picking up the access key. I will just paste it here for convenience later, the secret, and I'm done. So getting back here to the cluster management, opening our application cluster. Actually, apologies, it's under explore cluster, workloads, pods. And if I do check the logs here, because I'm able, as we can see, listening for jobs. So our deployment agent is good to go. And yeah, I did forget the application itself that we were so keen on seeing. Looks pretty normal to me. Everything's running, it's exposed, as you can see. We can do some adding. This is not linked to any database, so it won't be saved anywhere, but still we can see it here. And now what we are going to do is we are going to do a deployment through the CI/CD. So we would be going to deployments, and we would be picking up the API that we needed. So the API is the URL itself, and I'm going to paste it here. So now going back here, and under our pipeline, under our repo, we can see the pipeline, which I will shortly describe. But as we can see, we have a variable group that would contain our variables. Variables in ADO are under libraries, and here is the variable group, and we have these three things that I've just copied. So we have our token, which is the access key. I have the secret, apologies, I have the API, which I'll be pasting here, and our secret key that will be pasted here. So I will be saving this, and we are almost good to go with the CI/CD process. Another thing that I will need to do in our AWS account is create a user which will be used to service connection in order to be able to link AWS to Azure DevOps. So under users, this is required for our ECR. That's why I'm going to call it ECR service account. And the only thing that I will be attaching is the container registry full access for more convenience, and I'll be creating it. And this user, I'm going to create him access key, which will be used by third-party service in the phase of Azure DevOps. So here is the access key. Next, I'll need to go to project settings, and I'll need to set up the service connection, which will be called the same name, ECR service account. Oh, sorry. Here we're looking. Oh yeah, now it's better. And I will need the secret access key, and here is the service name where I need to describe it, ECR service account, and I will be saving that. Okay, so we have the service account, everything is set up and it's ready for deployment. We will need to create a pipeline, of course. Here from Azure GitOps, it's DevOps and it's this, but we won't be running it. We will just save it. And now I already have my repo here open. So I'm not much of a developer guy. So the easiest thing that I can show you is changing the header font with something different that we would be having. So for example, let's say that we want to make the color a bit more green. So this is RGB. So we would be changing maybe this to 1 and picking up more green during the way. So yeah, this is green. And another thing I'll need to do is git add git commit changing header color and git push, and it will require a password, so I'll need just to pick it up from here, clone, generate git credentials, here is it, pasting it here. Okay, and now this must trigger our pipeline automatically, which is the case, but we will need to do some approvals on 3 of the new resources that we've created. So this is our agent pool that it's used for the deployment, the variable group that we are using for the variables for the rancher, secret key, API, and the service account. Okay, so everything now is set in place, and if we go to the, we can see that we have 2 jobs, build and deploy, and I'm going to go through them. So in repos, if we check the Azure pipeline, we can see that we have a trigger that's main. That means that anything that changes under the main branch, it's going to automatically trigger the pipeline. We have the variable group that I previously shown you, and we have 2 jobs. One of them is the build, and it's using the Ubuntu latest image. The steps are just 2 of them. The Docker task that will be building our image, and afterwards we would be using a predefined ECR push image task from Azure DevOps presented to us. We just need to specify those things, and here, as you can see, is the AWS credentials. So this is the service connection that will be allowing the Azure DevOps to push image to the repository itself. And afterwards we have a deploy, which depends on the build. If the build is successful, it will trigger the deploy only then, and it's using shell script. And in the shell script, it's not the scope of this presentation, so I won't go through that, but there will be a GitHub repository with all the files that you need, all the explanation, the presentation would be there, but it will be using a shell script, and the shell script will be using the API that we've provided. So here is the rancher deployment API that we'll be using, and the access key and the secret access key. And while we are waiting on this application to be built, there is something else that I would like to show you. So there is user and authentication here, and there are different authentication providers. Personally, in my experience, we are using Azure Active Directory, and it's an amazing thing to link it. It's such an ease to work and to manage different users and their permissions with that. So what I want to show you is create another member, another user. So let's call it John, for example, and John, as a description, will be a developer. We will be generating a random password for him that we would have here stored somewhere, just to have it, and he will be a standard user. I will just allow him to view rancher metrics, for example. So this wouldn't allow John much to do, actually. So we would need to go here under application cluster, and under project and names, sorry, not project names, but cluster and project members, we would need to add him. So we are going to add him to the cluster membership. He will be a member, and if we type John, we can find him. And the other thing that we would need to give him access is the project membership. So we would be adding it to the default project. This means our application where we've created it, and we will be giving him read-only access. Since he is a developer, it would be good for him to have read-only access, which will allow him to debug or to investigate simple issues, check the logs, for example, and see the resources of the machines. So he can present this to a guy with more knowledge, a DevOps role, for example, or system administrator. It doesn't matter, and it will just ease the whole process in debugging and finding the reason for an issue. So we would be adding him here. Well, we see, okay, you can see that our pipeline has been successful. The build and deploy step, everything has run successfully, and it has been updated. So actually, if we go here and if we refresh, I think that it might have cached, so I'm just going to use a private window. Okay, for some reason it didn't pick up the changes that I've deployed. I will just do another pipeline run from here just to verify, but first I'm going to check the commit that I did and see. Oh, apologies, we are not here. I'm going to check the commits that I did. So changing header color. Okay, yeah, it indeed must have picked it up. So I'll just trigger a quick pipeline here, another one. I would be assuming this is caused by because the image had the same name. So if we go to the repository itself, we are going to check that. As you can see, one of them, it has removed the tag, and the other one, it's using the new one. Okay, so now I'm going to use this new private window here, so I can log John in, and we can see what actually John can see. So John is here, and we are logging it. And as you can see, he can see the application cluster. The local one he can't see. He sees only the one that we've given access. So he sees the monitoring and all of that. So he can go here. He can check the workloads. As you can see, he sees only, if we go to all namespaces, since this is the project, this is the only thing that we've deployed. So he can actually check and only view logs, for example. So we can see that everything is from the 200 from the liveness probe that we've created early. He will be able to check, as I did explain, the different CPU and memory usages, so he would be able to provide a better detailed information why the application has failed, and a guy with a DevOps role or system administrator wouldn't need so much time to investigate this. So while we wait on the build, which would be shortly finished, I will just go back to the presentation, and I'm going to present you here the different materials that you would be able to access in the Accedia GitHub repository. Also, there would be the sample Angular application from where I did pick it up because I haven't written it myself. Also, how to install AWS CLI and kubectl. These are things that we did use in the background. The documentations are pretty detailed, so I don't think you would be having any issues in installing any of those tools. Also the self-hosted agent that we've pushed. This is something with Azure DevOps, so it's from Microsoft. And also you would be able to contact me on any of these two, the LinkedIn profile and my personal email for any help or further explanation if there is an issue with setting up the Rancher cluster. In conclusion, I would like to say that this tool provides a really powerful options for you to manage multiple clusters. It's really convenient to use. It provides auto-authentication, out-providers, I should say, and it's really convenient for adopting containerized applications, and it's really easy for new people since it's using a UI and it's not a CLI. I still prefer the CLI, of course, as a DevOps guy, but for developers, this is a great tool to help them, other colleagues, in investigating issues. So, as we can see, the deployment has finished, and if we do come here, and if we do update, Okay, so the color has changed, so the deployment has been successful. We can even go here under application cluster, under workloads and pods, and we can see that our application has been deployed 1 minute ago. So yes, thank you for your attention and for your time. I hope that this demonstration and presentation as a whole would be as an interest to you as it has been to me. And yeah, goodbye.